So we're looking at my prototype board here, and I've got my debugging console running connected to the serial port. And I guess before I flash the code, I'll talk about what's on the board. So there's this is an ESP8266. It's it's got its own little carrier board with a transistor switch set up so that I can hard cycle the power on the radio. I've got excuse me, I got like a logic analyzer hooked up here, another logic analyzer hooked up here for decoding. This is the debug UART. It's actually the debug console, and it's hooked up to the pins there for one of the UARTs. I got a display here which I haven't finished implementing. It starts up and gets it exactly to where it is, and that's it. Probably should, for the ease of doing stuff, like turn the backlight off. But also there's an EEPROM over here, a TTL level converter, and a 12-bit ADC over here that works in differential mode. The channels are out in differential here, and they go to a passive signal chain that's just right now resistors, and that's it. This is obviously an STM Cortex-M4. It's the 429. It's got like loads of peripherals, loads of pins, and it's got a mega flash and like 256K of RAM. So I'm going to flash the code now, and we'll see it start up. So it goes through some hardware initialization and stuff, giving me basic information about the system. And I can type help and get some of the commands for the debug console. It's high level. It's not really fully fleshed out yet, but I have the ability to look at and work with some tasks and look at memory, and then reset via software reset. So I can reset it, and as you notice, the power marker said software forced reset. So I can look at see what tasks are running, get help on that task. So I can get help in there, see what I can do. I can list them all, suspend them, or resume them. Now, suspend all and resume all really don't, they mean everything except for the control task and the idle task, obviously. So what you can't see, because there's light going on, there's a LED over here, and those LEDs have a driver that lets me see with a glance. I usually don't have the light above on when I'm working on it. It makes it easier to see the LEDs over here. But this LED that you see, my finger helping reflect, is the idle task. So that lets me know that the idle task is running. Like all good things, the hardware watchdog is pet inside of the idle task, so that if all the tasks don't get to run, including the idle task, it'll automatically reset the system, and then once it resets the system, the power indicator will say that the independent watchdog reset it. So I got there's also some LEDs there for asserts firing and stack overflows, heap out of memory. All of these, there's a bunch of LEDs over, there's like 4, and they're set up for that. So as you can see here, the control task and the idle task are running, and the other tasks are blocked. So if I say I want to suspend them all, and I list, again, idle task is running, control task is running, all the other tasks are suspended. I can resume them all, and they all go back to running. They're, right now blocked because they're not really doing anything at the moment. I'm still working through driver issues for I2C, for the ADC, the EEPROM, and the display. An earlier version of this had a rough driver for the radio, and that was pretty cool. I just haven't gotten back to working on the radio driver. So I also have the ability to look at the memory. So I can see, you know, I gave it a 64K heap, even though I have 256K of RAM. Obviously I've got 52K roughly still not doing anything, so I don't need to add anything more, and the stacks are barely being used. So this is not that far along, obviously. So yeah, so I've got it organized into application and hardware access and all this stuff in the code, and the code's fairly neat, I guess. Makes it kind of decent to work in. Like, for example, here's iterating over the stack to build the high water total and used in the max total, as well as print out information about each one of those tasks that's running. I have a system handle here that is nothing more than, right now anyway, nothing more than a list of the tasks that are running, and so I can iterate over it and display the stack usage. And every time you call this, if these were working back and forth through functions contained within each task, and they were using and then letting go of their stack memory, these numbers might change. Same with the heap, right? So right now, the only thing using the heap right now is, consequently, the heap command. So I grabbed some heap. I thought I did. Maybe I didn't. I grabbed the free heap. No, that's right. Not that one. It's up here. The only thing using the heap right now is the list. So I'm using the built-in list command, task list from FreeRTOS, to get the message, and then I'm freeing it. So currently, that's the only thing using the heap as set up in FreeRTOS. Interestingly enough, the debug UART is also using some FreeRTOS stuff. It's using a binary semaphore. So when I try to receive a command from the debug UART, I am guarded by a semaphore, and that semaphore is given from the ISR, or the interrupt service routine. So I receive a bunch of bytes, and I wait until I receive a carriage return and a new line, and then assume that if you hit enter, you're giving a command, and then I wake up the task by giving the semaphore, and then using the new feature within FreeRTOS, where you can determine if another task was awoken because you gave an ISR up. So when that is the case, which that's always the case in this implementation, it will yield from the ISR directly to the task that was woken. And in this case, it's going to yield directly. Where is it? It's going to yield directly to. The heck is it? Here it is. So it's going to yield directly to this task, because control task is the one calling HAL debug UART read, which takes the semaphore. So it'll immediately go from this ISR right to this spot, give the command, work through the command structure, and do whatever it needs to do. So, yeah, I'm rambling. Alright, thanks.